There are estimated to be 100 billion stars in our galaxy alone. Recent data suggests that most of these stars have planets. That means there are potentially trillions of worlds in the Milky Way. Statistically, Earth cannot be the only planet with life. So, where is everybody? This is the Fermi paradox, and today we are not looking at science fiction. We are looking at the hard data. How do we find planets light years away? What makes a planet habitable? And what happens if we actually find something looking back at us?
For centuries, humanity looked up and wondered, but only in the last 30 years have we had the technology to prove we are not alone in the universe. In 1992, the first exoplanets were confirmed. In 2009, NASA launched the Kepler Space Telescope. Since then, the count has jumped from 0 to over 5,500 confirmed exoplanets. This isn't just about curiosity. For the American space industry, from NASA to private companies like SpaceX, understanding exoplanets is the next logical step in human expansion. If we want to know our future, we have to understand what else is out there. The search for life is no longer philosophy. It is astronomy.
So, how do we find them? We cannot simply take a picture. The star's light is too bright. The primary method is the transit method. When a planet passes in front of its star, it blocks a tiny fraction of the light. Think of a fly passing in front of a car headlight. From miles away, you wouldn't see the fly, but you would see the light dim for a second. That is what Kepler measured. Another method is radio velocity. A planet's gravity pulls on its star, causing the star to wobble. We detect this wobble through shifts in the star's light spectrum. These methods tell us the planet's size and orbit, but they don't tell us if anything lives there. For that, we need to know where the planet sits.
Astronomers call it the Goldilocks Zone. Not too hot, not too cold. It is the region around a star where liquid water can exist on a planet's surface. Water is the solvent for life as we know it. In our own solar system, Earth is in this zone. Venus is too close, the water boiled away. Mars is too far, the water froze. But exoplanets vary wildly. Some orbit red dwarf stars, which are cooler. The habitable zone there is much closer to the star. However, being in the zone is not enough. The planet needs an atmosphere to retain heat and protect from radiation. A rock in the Goldilocks zone without an atmosphere is just a dead desert. This brings us to the next technological leap. In 2021, the James Webb Space Telescope launched. Its job is not just to find planets, but to analyze their atmospheres. When starlight passes through a planet's atmosphere, certain chemicals absorb specific colors of light. We call these biosignatures: oxygen, methane, carbon dioxide. On Earth, oxygen is produced by life. If we find high levels of oxygen and methane together on an exoplanet, it is a strong indicator of biological activity. JWST is currently analyzing planets like TRAPPIST-1e and K2-18b. Early data shows potential signs of carbon-bearing molecules. It is not proof of life yet, but for the first time in history, we have the tools to check. We are moving from guessing to testing.
We have the numbers. We have the methods. We have the technology. The probability suggests life should be common. Yet, the universe remains silent. Whether we are the first, the last, or simply alone in this sector of the galaxy, the search defines us. Here is the question for you. If we found a planet exactly like Earth, but 50 light-years away, would you take a one-way trip to colonize it? You cannot come back. Let me know your answer in the comments. If you want more data-driven space analysis, subscribe to the channel. We break down the science without the hype. Thanks for watching.